diniscuss natin different refrigeration cycle. So, ngayon, discuss naman natin refrigerating machine and reverse Carnot cycle. So, saan nag-start yung idea of having vapor compression cycle. So, like yung mga Rankine cycle natin sa thermodynamic cycles. So, nag-base lahat ng yon sa Carnot cycle, which is the ideal cycle that gives higher efficiency. Pero again, ideal lang siya, hindi siya ginagamit in actual operation kasi hindi siya possible. But yung idea of the use nowadays are based on Carnot cycle. So, like that, ganun din dito sa refrigerating machine natin. So, we'll be discussing the reverse Carnot cycle naman. Okay? So, we'll be discussing also this SI units para you will be aware then and then ma-familiar kayo and also bigay natin saglit. Araw. So, meaning, kailangan natin or yung ton of refrigeration natin is yung amount of heat required para ma-convert natin yung 1 ton na water at 0 degrees Celsius to 1 ton of ice or doon sa ice at 32 degrees Fahrenheit or 0 degrees Celsius. Clear ba tayo doon? So, para mas madaling maintindihan, for example, meron tayo ditong water, pero basta, para lang may distinction tayo. Okay na ako. Oo. Oo. Wait lang. Okay. So, again, dun sa ating kanina, na-discuss nyo ba sa heat transfer yung amount of heat na or paano mako-compute yung amount of heat in order to freeze water? Hindi. But in this case naman, ano yung amount of heat na in order to convert natin? Kasi again, meron tayong sensible at latent heat. So review natin, sensible heat is the amount of heat remove or add into a certain substance in order to latent, sensible is in order to without change in phase, but with change in temperature, so that is sensible heat. Pero yung latent heat natin, kagaya nito, amount of heat required or amount of heat removed or added into a certain substance in order to have phase change without change in temperature. So in this case, para mahanap natin yung ton of refrigeration, mas kailangan natin malaman yung heat required para ma-convert natin itong 1 ton of water at 0 degrees Celsius or 32 degrees Fahrenheit into ice, which is 0 degrees ice or 32 degrees Fahrenheit ice. Clear ba tayo doon? Okay. So meron tayong latent heat of fusion and latent heat of vaporization. But in this case, latent heat of fusion or latent heat of freezing of water ang gagamitin natin. So that is the amount of heat. So ibig sabihin ito, yung 144 BTU per pound, ibig sabihin yung amount of heat na matatanggal doon sa water para maging ice siya from 0 to 0 degrees Celsius ice is 144 BTU para sa isang pound of water. Naintindihan? So para ma-convert yung isang pound or 1 pound of water to ice, both at 0 degrees Celsius, ang mariremove is 144 BTU. Clear ba tayo doon? So ganun din, kung yung ice magkakaroon ng phase change sa water both at 0 degrees Celsius, ang maa-add naman doon sa ice is 144 BTU para maging water siya. Clear ba tayo doon? Pataas naman ako ng kamay kung clear tayo doon. Okay, so ibig sabihin, para ma-convert natin yung 1 ton of water, so para ma-convert natin itong 1 ton of water, papunta sa 1 ton of ice at 0 degrees Celsius, kailangan natin mag-multiply ng amount of heat per pound. So, kailangan natin i-convert itong 1 ton of water into pound. So, 1 ton of water to pound is 2,000 pounds. Clear naman tayo sa conversion. Naalala mo yung conversion na yun? 1 ton is equal to 2,000 pounds. And then i-multiply natin yung latent heat of fusion. So this is the amount required in order to convert 1 ton of water at 0 degrees Celsius to 1 ton of ice at 0 degrees Celsius. So that is 144 BTU per pound. So ibig sabihin, para ma-convert natin yung lahat ng 2,000 pound, i-multiply natin siya sa 144 per pound. So cancel natin to. And as you can see, ton of refrigeration per 1 day or per 24 hours. Kaya siya dinivide ng 24 hours. Okay? So therefore, ang 1 ton of refrigeration in BTU per hour is 12,000 and then BTU per minute is 200 BTU per minute. So that is in English unit. So for metric unit naman, 1 ton of refrigeration is equivalent to 3,024 kcal per hour or equivalent to 50.4 kcal per minute. So, ginamit lang yung conversion natin dun sa mga previous slide. And then, para naman dito, SI unit naman, gagamitin natin is kilojoule per minute. So, that 1 ton of refrigeration is equivalent to 211 kilojoule per minute or equivalent to 3.52 kilowatt. Okay? Any question on this slide? Clear naman tayo sa slide na to. So, that is for 1 ton of refrigeration. Any question? Pataas naman ako ng kamay kung clear tayo sa slide na to. Okay, so yan yung unit of refrigerating capacity. So pag may nakita kayo na ton of refrigeration, or refrigerating capacity, so meaning yun na yung ating QA or heat added dun sa evaporator natin. Clear ba tayo doon? So now, let us now move on. So dun sa discussion natin for heat engine and refrigerating machine. So a system operating in a cycle and producing a net quantity of work from a supply of heat is called a heat engine. So from this, as you can see, yung arrow natin is from hot reservoir to cold reservoir. So, meaning, ibig sabihin, yung temperature difference ng ating hot reservoir pupunta dun sa ating cold reservoir, parang ginamit siya in order to have work output kagaya nung dun sa steam turbine, heat engine. natin. So, sa interview, nagkakaroon or pinapaikot ng blades yung gamit yung high temperature, high pressure steam. So, ibig sabihin, through doon, nagpo-produce siya ng output work. So, ginagamit yung heat in order to work kasi para mapababa or magkaroon ng mababang temperature. Pero, dun sa refrigerating machine natin, so hindi spontaneous yung process na pababain ng temperature below that of the surrounding. Kaya magkakaroon tayo ng work input sa refrigerating machine. So yun yung pinagkaiba ng ating heat engine at saka ng heat pump or refrigerating machine. So in this one, kapag ka nagkaroon tayo ng energy balance sa ating heat engine, sa engine natin, so ibig sabihin, papasok positive, palabas negative. So QA natin papasok minus QR minus work plus palabas pala minus, so is equal to 0. So in order for us to get the work, lipat lang natin to sa kabila, then therefore QA minus QR yung work natin. Okay? So in this case, yung work natin is equivalent to QA minus QR, and then efficiency of engine natin is work over QA. So since our work natin is QA minus QR over QA, since ang work natin is QA minus QR, so therefore ang efficiency natin is QA minus QR over QA. So that QA natin is the heat supplied, QR is the heat rejected, work is the net work, and E is the thermal efficiency. Okay, any question on this slide? So take note that this is our hot reservoir and that this is our cold reservoir. So this is the receiver of heat. Ito yung source of heat natin. And yun, pwede pa tayo makapag-produce ng work output. Any question on this slide? Okay, so I think wala naman na lang. So heat engine, yung kanina, so ngayon naman is refrigerating machine. So ibig sabihin, refrigerating machine will either cool or maintain a body at a temperature below that of its surrounding. So na-discuss na natin to last week about definition of refrigeration system. So a refrigerating machine may be represented by the diagram shown in this figure 1-2. So the machine R absorbs heat QA from the cold body at temperature T1 and rejects heat QR to the surrounding at temperature T2. Okay? So in this case, ito yung ating cold body. So it removes heat. It removes heat from the cold body and transfers it to the surrounding. Ganun yung ginagawa sa refrigerating machine in order to maintain or cool this cold body. Okay, so refrigerating machine or dun sa refrigerated space natin. So in order for that to work, so we need to work or we need to apply work on the refrigerating system para ma-maintain natin yung temperature below that of the surrounding. So if magkaroon tayo ng energy balance sa ating refrigerating machine dito, so QA natin is papasok din yung work natin, palabas naman yung QR which is equal to 0. So therefore, work natin is equivalent to QR, ito negative, dilipat sa kabila, minus QA natin. So therefore, work natin is equivalent to QR minus QA. Dito yun. So the performance of a heat engine is being expressed as thermal efficiency, kagaya ng kanina, which is work over heat added. Pero, yung ating refrigerating machine is being represented as coefficient of performance. So the performance of a refrigerating machine is expressed by the ratio of useful result to work, which is called energy ratio or coefficient of performance. Since ang main function ng ating refrigerated space or ng ating refrigerating machine is to maintain a body at a temperature below that of the surroundings. Ibig sabihin, ang gamit niya talaga is to remove heat from the cold body. Kaya yung pinaka pagkuha ng coefficient of performance is yung heat added dito. Ito, QA over work input. Kasi again, para malaman yung performance is equivalent siya sa heat absorb heat absorbed from the cold body divided by the work input para ma-maintain yung cold body sa temperature below that of the surrounding or ma-maintain yung cooling effect. Okay? So, coefficient of performance ang tawag doon. So, that is equivalent to yung Q added dito. Sabihin, this is from the body na gusto nating palamigin. Yun yung mariremove sa space ng refrigerated space natin. Pupunta doon sa refrigerating machine natin, which is, dun sa mga na-discuss natin, is pupunta sa evaporator. Clear ba tayo doon? Divided by yung work sa compressor para mahanap yung CVP. So, QA is the heat absorbed from the cold body or refrigeration produced. So, yung QR natin is the heat rejected to the surrounding. Work is the work done, and COP is the coefficient of performance. Clear ba tayo sa slide na to? Any question? Clarification? Okay, so now let us move on to our next slide. So let us review process in Carnot cycle. So Carnot cycle is the ideal cycle. Okay. So all of the processes in Carnot are reversible. Sabihin, itong process kasi na to from temperature 1 or hot, punta dun sa T2, kagaya ng ating heat engine. Ito yung TS diagram for heat engine natin. So process A to B, this is the heat addition sa boiler. For example, kapag rankine. So dito may heat addition, dito naman may heat rejection, dito naman may work output. Okay, in Carnot cycle. So this is isothermal heat addition. We have isentropic expansion. C to D we have isothermal heat rejection, and then D to A isentropic compression. So as you can see, our S or entropy B is equal to entropy C, entropy A is equal to entropy D. Temperature A is equal to temperature B, which is equal to T1. Temperature C is equal to temperature 2, which is equal to temperature 3. Okay. So, ganun din kanina. Nag-energy balance tayo. So, QA, papasok, minus QR, palabas, minus work, is equal to 0. So, for us to get the work, that is QA minus QR. Ito yun. So, compute, or formula natin to get heat is T delta S. So, to get natin, or to get the value of QA, since QA is at, nasa T1, so T1 delta S, which is SB minus SA. So, ito yun. So, yung QR naman natin is at temperature 2 or low temperature divided by SC minus ST. Or equal, since SC is equal to SP dito, and then SD is equal to SA. So, this is our QA, this is our QR. So, substitute natin siya dun sa nakuha natin for work. So, work natin is QA minus QR, substituting the value for QA, so that is T sub 1, multiplied by the quantity, SP minus SA minus T2 times SP minus SA. So, since meron tayong same factor dito, ilabas natin siya. SB minus SA. Then, multiplied by, ang natira sa first term ay T1. Ang natira naman sa second term ay T2. Operation ay minus. So, minus T2. So, binaliktad lang siya dito. Kaya T1 minus T2, ito, nandito. Kasi multiplication naman siya. SB minus SA. So, work natin ay quantity of T sub 1 minus T sub 2 multiplied by the quantity SP minus SA, or change of entropy. So for us to get the efficiency, since this is Carnot cycle, meron tayong work output. So therefore, efficiency natin is work over Q added QA. So work, substitute the value of work, and then substitute the value of QA. So since meron tayong same factor, cancel natin ito. Efficiency natin is T1 minus T2 over T1. So this is the efficiency of the Carnot cycle. So again, QA natin is heat added, QR heat rejected, work done, thermal efficiency. T sub 1 is the temperature of the source of heat, and then T sub 2 is the temperature of the sink or the receiver of heat. Okay, any question dito sa review ng ating Carnot cycle?
Wala naman po.
Okay, ano yung question? Any question? May question ba?
Wala naman po.
Okay, so now let us now move on to the next. So this is the reverse Carnot cycle. So all of the processes in Carnot are reversible. So dito naman, from process A to B, we have isentropic compression from A to B. So kung sa vapor compression cycle, nandito yung ating compressor. Dito merong work input, isentropic compression. From process B to C, heat rejection naman to sa condenser natin, isothermal heat rejection. So dito naman, so this is the isentropic expansion sa expansion valve, process C to D. And then dito A, nandito yung ating Q added. Ito yung ating evaporator. Or nandiyan yung ating refrigerated space. Dito nangyayari yung refrigerating effect or cooling effect. Clear ba tayo doon? Okay. So, nandito din naman yung ating So again, ito yung ating heat rejected sa condenser. Ito yung work input natin, compressor muna. So A to B, isentropy, compression. So work input. B to A, B to C, so that is the isothermal heat rejection. C to D, throttle, valve, expansion, isentropic expansion. And then meron tayo ditong QA sa evaporator or yung heat added natin sa evaporator. So yung QA at yung heat added, so yun yung heat na nare-remove sa ating refrigerated space. Or you can say that this is our refrigerating capacity, QA. So if magkakaroon tayo ng energy balance, papasok natin is work, palabas, papasok din ang QA, palabas ang QR is equal to 0. So work natin is equal to QR minus QA. Ito yun. So QA, as you can see, ito yung heat added natin. So that is T1 multiplied by delta S. So SA minus ST. So dito naman natin, ito, dito, so T2 times SB minus SC. Since SB is equal to SA and SC is equal to ST, so same para magkaroon tayo ng common factor. So T sub 2 multiplied by SA minus ST is also equivalent to our refrigerate sa heat remove. So work natin is equivalent to our QR minus QA, yung nakuha natin kanina. So heat rejected natin is T2, substitute lang natin yung value. So SA minus ST minus T1, yung QA natin, which is T1 times SA minus ST. So yun, common factor ulit natin is itong change in entropy multiplied by T2 minus T1. So this is our work. So in order for us to get our coefficient of performance, meron tayong QA at work dito. Okay? So QA divided by work. So QA natin is T1 delta S divided by T2 minus T1 delta S sa work natin. So cancel since same factor. So COP natin is T1 over T2 minus T1. So you have to take note of the formula for COP in reverse Carnot cycle. So A is heat absorbed from the cold body. So again, as you can see, heat absorbed from the cold body. Sabihin ito nga yung heat galing dun sa refrigerated space. Heat removed. So QR, ito yung heat added sa refrigerator, pero ito yung heat na nare-remove sa refrigerated space. Kung meron tayo ditong refrigerated space, ito yung nare-remove palabas siya, pero papasok siya ng evaporator. Kaya papasok siya ng system, ng refrigeration system. Clear ba tayo doon? Pataas naman ako ng kamay ko. Clear tayo doon. Okay, so T1 natin is the refrigeration temperature. Ito yung nasa baba. And then T2 natin is the heat rejection to the surrounding. Okay, Okay, pataas naman ako ng kamay kung clear tayo dito. Kung clear tayo dun sa last slide natin. Ayan. Okay, so for this one, kindly read the problem, Aldrich. And then I will be requiring everyone to solve and provide yung TS diagram with its corresponding hit added, hit rejected, and work. TS diagram muna tayo. So I'll give you 5 minutes para maano yung sa TS diagram. So you also need to put yung mga given temperature sa TS diagram. Kindly read the problem, Aldrich.
A refrigerating system operates on the reversed Carnot cycle. The higher temperature of the refrigerant in the system is 120 degree Fahrenheit and the lower is 10 degree Fahrenheit. The capacity is 20 tons. Neglect losses.
Okay. So I'll give you 3 to 5 minutes to draw the TS diagram and then send it sa ating GC. Kahit TS diagram muna. Then we will solve the problem later. Okay, so I will also give you 15 minutes to solve this problem. So you have to try to solve this problem. So using all of the conversion and also yung formula na na-discuss natin. And then we will discuss this after 15 minutes. Clear ba tayo doon? Pataas naman ako ng kamay. Okay. one page per problem, pero hindi naman siya kasi baka sayang yung papel. Ano? And then, yun. So, iti-discuss natin next week is yung part 2 ng ating lecture. So, bale, ang pag-discuss noon ay per student slide. One slide per student. Clear ba tayo doon? Yes, Justine.
Question lang po dun sa problem set.
Yes.
Engineering lettering ka po dun.
Hindi naman kayong bahala. Pero, as long as tama yung sagot, at saka okay yung flow, ano? So, basta maayos ang sulat, ano, naintindihan. Kung kaya namang engineering lettering, edi engineering lettering para mas okay. Pero kung, so ayan, as long as kita yung sulat, hindi naman ako nag-base ng marka sa sulat. Basta tama yung sagot, tama yung flow, hindi tinulat. Ano? So, yun. So,
Lalagyan pa po ba ng border?
Invisible. Invisible 1 inch margin each side.
Okay po. Thank you po.
Okay. Any question pa? Okay, so dito, didiscuss natin last week. Sino nga yung ating class monitor? Sorry, hindi ko pa din naaalala. Yes, yan, si Janelle. Yeah. So, bali, may listahan naman na kayo ng alphabetical arrange ninyo.
Yes po, meron na po.
Pa-screenshot naman ako noon yung mga names para alam nila kung anong number sila. Tapos pa-share sa GC. Ngayon. Kaya ba i-screenshot ngayon?
Yes po, ma'am. Wait lang. Send ko po.
Tapos pa-share ako sa GC bago natin to. So, bali, ang magiging discussion natin last week, si Janella, ikaw ang mag-share ng ating PowerPoint. So, download mo, tapos ikaw mag-share ng PowerPoint sa class. Tapos each of you will be discussing each slide. So, kung ano yung mapatapat or mapa-assign na slide. So, since kesa iwanan ko to sa inyo as reading materials, edi each one of you will be giving inputs. So, kung ano yung mapa-assign na slide sa inyo. So, ayun. Kasi mostly dito ito talaga ay babasahin. So para at least mabasa siya during class. Para ma-explain din siya during class. Okay? So, lahat tayo ay naka-join sa Meet. Pa din. Okay. Na-share na Neng yung
Yes po, ma'am. Nasend ko na po sa GC.
Ayun. So, para naman sa iba, para sa lahat, So, tingnan niyo naman kung anong number nyo dito sa listahan. Para pag nagbanggit ako kung anong student number naka-assign yung slide, alam niyo na kung alin ang mapapatapat sa inyo. So, don't worry kasi ito naman ay one student per slide lang. So, bale, before tayo mag-meet, you are well aware or well-informed, well-researched dun sa slide na naka-assign sa inyo. And then during discussion, lahat kayo ay nakikinig na. Okay? Okay? Wag namang mape-pressure dito. So, as long as ma-explain mo yung slide mo, okay na yun. Okay? If, for example, meron kayong gustong ipa-add na figure doon sa slide, edi sabihin nyo lang kay bali ilagay nyo na lang to sa Google yung PowerPoint na na-edit siya online para nagsisave yung lahat ng pero wag na lang maglagay kung ano na lang, pero kung need talaga maglagay ng picture, di maglagay kayo. Okay? So again, one student per slide lang naman po. So alam na ba niyo ang number niyo? Pataas naman ako ng kamay kung okay na tayo sa numbering. Okay, so start tayo. Ito naman ay title page, so walang assign yan. So next, first natin Kasi ito, first slide, first student. So number 1, student number 1. Tingnan nyo na lang yung slide number dito sa baba kung ano yung mapapa-assign sa inyo. Hindi ko nababanggitin kung ano yung naka-assign. Basta sasabihin ko kung ano yung naka-present dito at saka kung kaninong student. Yun. So again, student 1. So this is student 2. Then 3, 4, 5, 6, 7, 8, 9, tapos ito ay sa 10. Itong slide na to, at saka to. Kasi ito babasahin niya lang. Tapos ito yung explain niya. Student 10. Clear ba tayo doon? Pataas naman ako ng 1 to 10. Kung okay, next tayo. Ito ay kasama sa 10, 2.1. Ano? So, 11 na tayo. Naulit lang pala tong slide na to. 2.1. Okay. Pero magkaiba yung laman niya. Kaya iba pa din to. Okay. So, sa ibang student na to. 11, 12, 13, 14, 15, ito ay 16, 17, 18, 19, 20, 21. Yun. Hanggang dito 21. Clear ba tayo? Pataas naman ako ng kamay. Student 11 to 21. Okay, so next tayo. 22. 22A ito. Babasahin lang naman to. And then ito, yung kanya. 22. Ito ay na-discuss na kanina, so hindi na to kasama. Ito, 23. 24. 25. 26. 27. 28. 29. 30. Then 31. Okay? Any questions so far? Okay, so next tayo 32. Itong 4, babasahin lang. And then start dito. 32. Okay? Then 33. 4.2. 34. 35. 36. 37. 38. 39. 40. Ito pala, 39. Same lang yan. Sa 39. Okay? 39 ay ito, tsaka ito. Tapos ito ang sa 40. And then 41. 42. 43. 44. 45. Okay, any question? Clarification? Okay, pataas naman ako ng kamay kung clear tayo doon sa next week. So, bali, si Inen, si Janela sa present ang screen. Lahat naman tayo nandito, open cam. Ano? And then, yun. Prepare nyo lang yung slide nyo. Pwede kayo mag-note sa inyo para ma-explain. And then, wag masyadong magpa-focus dun sa slide na ipe-present. Kasi magpe-present din yung iba. So, kailangan nyo maintindihan yung the rest of the slide. Okay? Any question? Okay, so how about dun sa discussion natin about Cardos, reverse Cardo? Any question? So, yun, ito yung magiging discussion natin for Saturday. And then, yan. Iba yung magiging discussion natin for the next week. Then, sa Sunday naman yun. Okay? Pataas naman ako ng kamay kung clear ang discussion natin today. Okay, hands down. So, ayun muna for this meeting. So, if ever na meron kayong question sa mga sample problem natin, so may sagot na nandoon. So make sure lang na minsan kasi hindi naman siya direct substitution lang, kailangan mo talaga siyang intindihin. So, kailangan lang talaga for you to remember na yung ilalagay mo na temperature doon ay yung absolute or in Kelvin or kaya naman ay in Dunkin. Okay? So, yun muna for today. So, yung problem set, wala pa naman siyang submission. Ano? Bale, siguraduhin lang na masagutin din. Pwede nyo naman diyang sagutan, pero yung submission, announce ko siya next week. Ano? Okay? Kasi yung hard copy niyan, sama-sama, isasubmit. Pero yun nga, that will serve as your review in every discussion na meron tayo. So, yan ay nasa student discipline nyo na. Ano? Kung gagawin nyo muna or hindi. Kasi mahirap yung gawin kapag kung kailan ipapasa sa kagagawin. Ano? So, at least meron tayo enough time at hindi magkakaroon ng problema sa submission. So, ayun. If you don't have any question, goodbye class and see you next week for our online meeting din. No? Goodbye class.
Thank you po, ma'am.